Can't get it. All right, folks. Good morning. It's about 5:30 in the morning. All of you folks in Bio 210. And we want to go to chapter 5 in your textbook. And that's on page 160. The Integumentary System. So as you look on page 160, you can see that, let's see, let me get this straight. You can see on page 160, we're talking about the skin. The integumentary system is a nice name for that, but it's really just our skin. And look, maybe it was. So we're on page 161, and you look at figure 5.1, and you see that I've got a nice illustration. So as you come down the left-hand side of that figure 5.1, you see you can divide the what they call the cutaneous membrane. That is another name for the skin for the integumentary system. So you have those three components. You want to know those three components, and we'll get a little deeper into their functions in a few minutes. Coming down, we're going counterclockwise, but you come down and you see the next label is sensory receptors. We have a number of those, and that's why you know the wind, when it blows, you can feel it on your skin, or as it is today with all the good rain we've had, we find we have some mosquitoes and you can feel them puncture your skin if you're not too absorbed in some other activity. So they would pick up various events on your skin, and you would know something was crawling on your skin. So you got sensory receptors. We'll mention those a little bit later. Some are in deep part of the dermis. Others are up toward the top. Then you see a rector pilae muscle. That we have little muscles associated with our hair follicles. And they can make our hair follicles stand up when we get scared. Coming around to the right, a little bit more, you see blood vessels there in the fat. Yes, we've got some fat under our skin. Helps to keep us warm. It's also a good cushion for protection. We'll talk about that later. And then you come around to where you see, well, it says adipose tissue there, so there's your fat. Sweat gland, you can see where those are located in the dermis. Coiled structure, and you follow the tube, the exit tube of the sweat that we produce all day long. We're actually sweating at this point, but you don't realize it, especially if you're inside a home where the air conditioner is working. The air is drier and the sweat will evaporate and keep you cool. It's one of the tough things in South Carolina. When it gets so humid, your sweat cannot evaporate easily and it doesn't cool you. So it's kind of tough when you live in this sort of climate that's very tropic in a sense. Then you come over to sebaceous glands. You can see three little projections there, and it's connected to what they have chosen not to label. That bulbous structure is a hair follicle, and then you see a hair coming out of it. So you want to know that diagram, and we'll add a few things to it as we go through the pages here. So let's go on over to page 162. And as you look at page 162, you come down that first column and you've got the functions of the skin. So you come down to protection, and it talks about protection from mechanical trauma. That's like, getting hit, bumping yourself or whatever. And it does a good job of keeping pathogens out. As one of the things that I think we mentioned back when we talked about the cell, how we have trillions of cells, somewhere around 37 trillion cells make up the body that we look at. And on the surface of the body, you've got 10 times more microorganisms. So our skin, when it's intact, it's not broken, is a good barrier. Little viruses like the coronavirus can't get through our skin. Now they can get into the respiratory system and create havoc, as we have learned over the last 3 or 4 months. But the skin itself can protect you. Then sensation, that's got those nerve endings that pick up breezes and so on. Then you have thermoregulation. Now this goes back to the very first part of where we started talking about homeostasis. So go back and review homeostasis. You can have other questions about that, but it helps to regulate our body temperature. There are a couple of examples over on the facing page, figure 5.2. And you want to, again, remember the components of a homeostatic mechanism. You've got a receptor, you've got a central control center, and then you've got an effector. An effector is going to produce some sort of a response to a situation. So anyway, make sure you go back over that. And then you come over to page 164, and you see excretion. Now, when we think excrete, a lot of times we think of waste products, and they come out through our sweat glands, and that releasing the sweat, which is meant to cool us, can also have some waste products in it. Doesn't sound real appealing, does it? But that's the way it is. And then the last one is this vitamin D synthesis. Now, I'd like for you to read through that. And I want you to notice some things. We're going to make a few connections. As you come to the second, you look at the first sentence there, plays a role in making the hormone vitamin D. Now, as you keep reading, you see vitamin D is actually created from the cholesterol structure. Now, you remember that? Oh, cholesterol, horrible cholesterol. Again, homeostasis, folks. You got to have homeostasis, got to balance there. So you read through that, and you'll find out how it gets changed, and it'll mention these big words like cholecalciferol, which enters the bloodstream, and then cholecalciferol is modified by the liver and then by the kidneys. It's a joint effort on our body to make this active substance that's going to benefit us. And so you see it says it's modified by the liver and the kidneys to become calcitriol. Calcitriol, active form of vitamin D. And notice why you need vitamin D. For the small intestine to absorb calcium. And then it mentions the necessity of calcium in our diet. But think about this. Now, everybody hates cholesterol, or some people don't care if it's high or low, whatever. But there are people who get fixated on getting rid of cholesterol in their body. It's homeostasis. Life's a balance, whether it's exercise or non-exercise. We need somewhere in the middle so that we have a healthy body. So read through that. Because if we don't have cholesterol in our body, then we could have a problem with vitamin D. Then when that's low, that means you can't absorb calcium. And then that can affect a number of activities in your body. I'm trying to get you to realize how things are connected to each other rather than just memorizing parts of the body. So make sure you read that. When you come down to the quick check, make sure you do those three. And just for the fun of it, where you see apply what you have learned, well, do that. Do that first one. And then you come down to the cells that make up the epidermis. Consists of these cells. This is a cell type, and that cell type is called a keratinocyte. Took me a little while to get the right emphasis on the right syllable. You got keratinocytes. So it's not except the horns of other animals. Now, you don't have to know that, okay? There are deer that have antlers, but cattle have horns, and that horn is actually hair. And you see in the next sentence down there, keratin, bold print term there. Let's see there. Here we go. Keratin, fibrous protein. What's its function? How does it get made? Got to go back. If you need to, somehow we might ask a question about that. Because you learned how proteins were made. You learned they consisted of amino acids. See, all this is what's in the past, and it can come back up into chapter 3 and this third exam that you'll have when you get back from the 4th of July week. Then that's a way to work older material in, because it's a building of information. We started with chemicals, and now we're into an organ system. Well, that's just the way it is. You had to learn 2 plus 2 before you could actually start playing with algebra. Okay, so let's see here. There we go. That's a little better light. You see, it's a tough tissue, resistant to mechanical stress, so it's there to protect us. And second, down there, you see it says keratinocytes are linked by numerous desmosomes. I ask you a question, didn't I? Those little connections between the cells that help to hold the cells together, but also in this case, they allow some substances to pass from one cell to another, not quite like a gap junction that is pretty open, very much open. And so you see it says the keratinocytes are arranged into layers or strata. So now what we want to do is look at the strata. You're responsible for knowing them. So they've taken a section on 165, figure 5.3, taken a little section. You look up at the left, and you see pretty much the same picture we had a few minutes ago, except it doesn't have the hair and so forth on it. But we're looking at the epidermis. And so you can see there are a number of layers. You can see them just visually, they look different. So the first one, we're going to work our way up from the bottom, is called the Stratum Basale. And so you can call it the Stratum Basal. That's the deepest layer. And you see down there in that a little section under Stratum Basal, single layer of stem cells. Now, stem cells have been a big topic in the last few years. And it's kind of interesting that you can take stem cells and out of one area and put it in another area of the body, and that stem cell will adapt to that new area of the body and sometimes regenerate tissue that's been damaged. Remember, we all came from one cell. I just get blown away when I think about that. That's a lot of fun to think about that. Anyway, they're closest to the blood supply. Now, they don't show in this middle picture any blood supply, but you can see the dermis. If you look at the first rectangle with all those layers, you look over look at the bottom and look just to the right of that block, that rectangle. You see dermis. Well, there are blood vessels in there. Okay, the tissue needs oxygen, needs nutrition, and so forth. Needs a way to get rid of waste material, and so there are capillaries, little tiny vessels that are 1 cell thick. Imagine a tube, very thin, and the tube consists of a single layer of cells. They have a word for it. They call it the endothelium. It's thin enough so that oxygen can move out and CO2 can move in. And so that enables the cell to have the nourishment that it needs. So you come on down into that paragraph. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8 lines. The cells actively produce the precursor to vitamin D. That means they've got to get cholesterol. All right? Don't have any cholesterol, we got a problem. We're going to be low on something. And you see it says precursor to vitamin D when ultraviolet radiation from the sun interacts with specific steroid-based molecules in the cell. So again, homeostasis in terms of that cholesterol. If you look in the next paragraph, you'll see in the 1, 2, 3rd line down, go to the right, and you see the word stratum germinativum. But that's what is going to happen here. This basal layer is going to germinate into the other layers and give us a covering that's a good protection for us. So we come down to the very bottom and you see stratum spinosum. You don't have to know why they call it that. You can think of little spines and so forth, but I'm not really interested in that. Over in the second column, look at the last line. They also help produce vitamin D. So as you look at the picture up above, in the middle, actually the picture over on the right is an actual microscopic image. You see in the right-hand corner of that right-hand rectangle, it says LM 485. LM stands for light microscope, parenthesis 485 times larger magnified than it normally is. So you see we got the stratum basal, and then you come to the stratum spinosum, which we just mentioned a little bit. Still helps to produce vitamin D. And as you look at the illustration, the middle rectangle, you see the stratum spinosum, and remember it's producing vitamin D. And you also see in there little dendritic cells. We'll talk about those in just a moment. And you look down there at the stratum basal, you'll see a little gray cell on the left-hand side of that rectangle. It says melanocyte, and we'll talk about that in a few minutes. And also the Merkel cell. So, stratum granulosum. You move up into the middle of that rectangle, and you'll see the term stratum granulosum. And most of you are thinking, well, that means it's got granules in it. That's correct. So we'll talk about where those granules come from in just a couple of minutes. As you look at the first paragraph of stratum granulosum, look at the last 3 lines. At least 2 types of granules are present in the cell. One type is keratin, and of course keratin is look at this, released from the cells by exocytosis. See how we're back in chapter 3 now? See all that you've got to remember this. How does that material get out to do what it's supposed to do? It does it by exocytosis. Is that active? Is that passive? Okay. See how questions can build up on there? So when you see things like that, and I point these out to you, Start making these connections, and you're building a big library of information concerning the body in which you live. As you look at the last paragraph on page 165, released from the cells by exocytosis, the lipid-based substance coats the keratinocytes in the stratum granulosum. And you see over there to the right, it says, and the more superficial strata of the epidermis, we're going to get up to that in just a second. Recall that lipids are hydrophobic, meaning they repel hydrophilic or water-soluble substances. So this coating acts as a water barrier. There's your waterproofing. It prevents the passage of hydrophilic into and out of the skin. So it actually helps to keep us in fluid balance, fluid and electrolyte balance. Now, some of you might say, well, how does it help in terms of electrolyte balance? Well, you've probably tasted your sweat before, right? And you and I are salty people. So that should answer the question. We don't want to lose too much salt. We don't want to lose too much fluid. Again, homeostasis. It is so central to health. And now come over on page 166, and you see the stratum, right? And then you also have that on the soul. That also protects us from losing too much water and so forth. We actually have sweat glands on our fingers. That's why we can get kind of clammy here sometimes. Let's go to Stratum Corneum. That's the top layer, superficial layer. There's another word that you should be familiar with, anatomy, superficial versus inferior or deep, or so to speak. Superior and inferior, and then superficial and deep. And those are terms that you should be familiar with. So the top layer, the superficial one, called the stratum. And so as you look at that, it says it consists of several, this is kind of funny, and dead layers of skin. So when you look at me in terms of this video, you're looking at dead skin. That's all part of the normal presentation we have. We don't think about that, but that's what it is dead skin. They've lost their organelles, as you can see, and they're just really sort of little packages of keratin. And you come on down. Let's see, what have I got there? Yeah, okay. I've got a note there. As you come down in that paragraph, you're going to see that we are always shedding keratinocytes. If we had the camera, we could see the little flakes falling off of us. We're flaky people. Now, most people would not want to be called flaky, but literally we are flaky people because we are shedding our skin. That's one way we control the amount of microorganisms on our skin. We shed our skin and they fall somewhere. Everywhere we go. This shirt that I have on is picking up cells that are coming loose from my body. Just got out of the bed. It's about 6 o'clock already. How about that? So I left a lot of skin cells on the sheets. Took a shower last night. A lot of skin cells got washed off of the body down into the drain and so forth. But the clothing you have on this morning and will wear through the day is going to pick up those cells. Your sheets get them. Your pajamas get those. That goes back to be cooled and dehumidified, and you have little flakes that get caught by the filter. And that's why you have to go change the filter every so often. You get dust in there, you get cells in there. And if you look at the last sentence, it just shows you how we are just surrounded by life. Notice it says in the last sentence there that our cells get eaten by mites. So when you crawl in that bed tonight, you're not alone. You got zillions of these mites in your bed. They're everywhere. They're on your carpet and so forth, and they eat your that come off your body. They recycle them. Now you think about nurses. You think about sometimes they have to monitor input and output. Well, input means you put it in here, out means it comes out the other end of the GI tract. The same thing is true for the mites. So pretty soon we're sleeping in a bed full of mites, dead skin cells, and mite manure. Something that eats something else, or eats the waste products of something else. So it's an interesting cycle. Obviously, we can get along with that. You've been doing it for 18 or 20 years or so now. Okay, so now you know the 5 layers of the skin. So go over to page 167, and you want to look at the quick check there. And then you come down to the little section that says other cells. So there's a good flashback because you're about to get into a phagocyte, the dendritic cell or Langerhans cell. Now remember, there's a picture of that on the previous page. Remember, you want to be able to identify those structures on page 165 as you look at that section of the skin and you see a dendritic cell. Now, to some of you, you might be thinking that, excuse me, that is coming loose there. Dendritic cell is part of a nervous system, and it does sound like that. It's a little confusing, but this has got extensions out from the body, so that's why they call it a dendritic cell. You can call it a Langerhans cell if you want to. A guy named Langerhans is the one who discovered it, so that's how we name them. But if you saw Langerhans and somebody said, where is that? It does not tell you where it is in the body. And dendritic, which makes you think about the nervous system, but phagocyte. It's a epidermal phagocyte because it lives in the epidermis, in those layers, 5 layers. Merkel cells, they're nerve cells for touch, fingers. Sometimes you can identify an object through your fingers, can't you, with your eyes shut? And you notice at the base of the hairs. So those are nerve cells. You also have melanocytes up at the top of 167, and they produce the pigment. As you see, they're called melanin. Look at the range of color people can come in. Melanin is orange red to brown black, and of course, if you don't have any of that, what are you called? You can look it up. If you don't have any melanin, you are called a particular name. And you know how kids are. They can be really mean to somebody who's different from others. Okay, so much for that. And let's look at thick and thin skin. And we've already mentioned a little bit about that. It's going to protect you quite a bit. You come down to where you see the bold print term. And right above that, it'll talk about present on your hands and your feet. So no hair follicles, but they do contain sweat glands. Now on page 168, they're still talking about thin skin and thick skin. Now come down to the second paragraph and you see this bold print term that you may be familiar with. It's called a callus. Can develop calluses. When I was young, my father liked to fire, and so I would split wood. And even when I got older, and married and so forth, we heated our house with a buck stove. Really nice thing, nice piece of equipment. I like to fire. I like fire, and so I had a maul, big long stick with a heavy on it and split wood, and I had calluses across here. When I was an athlete, or a guitar, or a mandolin, or a cello, not taking a piano because that's got keys, but you have to put your fingers on the string, and those of you who have, excuse me, played that, you know you get a callus on the end of your finger. It gets thick. That's because that's sort of an irritation. You can get it on your feet also, and sometimes they can be real painful. But anyway, that's a thickened area to protect the area that's being used a lot, but sometimes it can create a painful situation, feet especially, where it's pretty firm and you can hold the strings down. And, excuse me, it doesn't hurt your fingers, but that's a callus. So we can develop wherever there's pressure. Okay, so let's leave that and let's come down to module 5.3 on 168. And you see the dermis of two let's look up. I want you to highlight in here. Up there to the keratinocytes, okay? Stay down here in the dermis. Most superficial layer of the dermis is the thin papillary layer. And you see they have that label, undulating. I have to get back from here, just up and down, up and down. That's the papillary layer. So notice as you come into this papillary layer section on the second column of page 168, come down 1, 2, 3, 4 lines. It says the papillary layer consists of loose connective tissue. Oh, there you are back in chapter 4. You see, keep it current. Okay, keep it current. Loose connective tissue. And got collagen fibers and elastic fibers in there. And you've got to line 8 at the dermis epidermis junction. Special collagen fibers extend into the epidermal basement membrane. That's the stratum basal. That's another way of saying the stratum basal. And so it says it anchors the epidermis to the dermis. Now you can peel it, you know, but that's what its purpose is that all those collagen fibers and elastic fibers help keep everything together. And so you come down to where you see about line 10 or 11, repetitive trauma, such as rubbing. You ever had a blister? Well, here's where we separated, because of pressure, the epidermis, that stratum basal, and the rest of them from dermis. And fluid gets in there, and we now have a blister. Okay? Now we're leaving that. We're coming down to the surface area of the papillary. This is the second paragraph. It contacts the dermis. It's folded into these projections, as you see there, and they're called dermal papillae. Now, what you want to notice is you look to the picture on the left. I've got this camera way up here. That's the middle of that figure 5.5. And you see the stratum basal and the stratum spinosum. They die because they're too far away from the capillary. Too far away from the capillary. So that's why we have dead cells making up the outermost layer. And so if you read in this paragraph, third line down says the dermal papillae house tiny blood vessels called capillaries. Now, capillaries carry blood. Capillaries is where exchange of nutrients and waste products occurs. Oxygen is a nutrient, so it goes out to the cells, especially the stratum basale and the stratum corneum. But then CO2 goes into the bloodstream, and you can think of other things. That's very important for the exchange of nutrients. You can just call them tactile. Tactile means touch. And you look at that picture again, figure 5.5. You look in the middle of the two pictures, and you see dermal papillae, epidermis, then you see tactile corpuscle. So that's tactile is touch. So you're aware that something's on your skin. And you come down to lamellated corpuscles, and you see they're built a little differently, but they pick up pressure that's a little heavier. Not just real light, but a little heavier. Okay? And you can see the Meissner's corpuscles there on our lips. Those are very sensitive, our face, and then our genitals. And so those are very sensitive. Meissner corpuscles help to know something's touching that particular part of the body. Just want to say one thing about the reticular layer. As you, on page 169, the first column says reticular layer. Then you see it says the deeper, thicker reticular layer is composed of dense, irregular connective tissue. Go back and think about that. How does it function? What's its purpose? Okay, let's look on page 169, second column, and you see skin markings. And talks about an interaction between the dermis and the epidermis. They talk about skin markings. We're not going to get into all of these things. Some of it's really interesting, but we just can't cover everything. Look at the last three sentences in this section under skin markings. The dermal papillae are extremely prominent. That means they show up a lot. Thick collagen fibers arrange them into ridges. Overlying causes indentions in the epidermis. You get ridges, fingerprints. Also, it's like tread on tires. So that's where we get our fingerprints. Okay, now we're not going to get into cleavage lines. How does the papillary layer of the dermis affect the appearance of the epidermis? That's our fingerprints. Okay. And then apply what you learned. Try number one. Just give it a shot. Start thinking. How do you apply that knowledge? Let's look on page 171, module 5.4, skin pigmentation. And so we come over to the right, and you see it says the primary skin pigment is melanin. And we mentioned that melanocytes are involved in, they're with a basal, stratum basale, and they produce pigment that we call melanin. Now, alphabet, tyrosine is one of them. What kind of a substance is tyrosinase? It's an enzyme, which means it fits into what category? Is it a carbohydrate? Is it a lipid? Is it a protein? Is it a nucleic acid? Okay, you should be able to answer that. That was covered back in chapter 2. Okay, we talked about all those classifications of substances in our body. And then you see it says the reactions occur in specialized vesicles. This is in the second column, about 5 lines down, 5 or 6 lines down, and you see it says melanosomes. Those are the vesicles in which melanin is produced. Now, let's look at this next paragraph. And you come down 1, 2, 3, the arms. Well, let's look at like that. Your book says, oh, but got these little projections. Now, look at the melanocyte. You see it's surrounded by cells of the stratum basale. Okay, basale. Basal. We put that's a herb, isn't it? People call it the stratum basale. Now, those are keratinocytes. Remember, all of those layers are keratinocytes. They just had given a different name because they change a little bit as they move toward the superficial aspect of the body. But look at the melanosome. It's kind of brown as opposed to a different color, maybe more red in those keratinocytes. But look at the melanocyte. You recognize anything in there? What's that little green stuff? What's that kind of little light purple sphere in there? What's that stuff around the sphere? Ah, you expect me to know that, Mr. Pritchett? Yes, I do. I'm trying to get you a good, solid foundation so that you can do well in 211 and eventually maybe microbiology. Anyway, remember the melanosomes. That's where the activity takes place to produce the melanin. And you see the little finger-like projections, okay? Sort of stick. They don't stick inside the keratinocyte. They just sort of push on the plasma membrane of the keratinocyte. And you come back up to this paragraph. We're in the second column, second paragraph. Come down to where number 2 is. It says of the figure that's within the melanocytes, melanosomes migrate to the tips of the arms where they are released by. You ever heard of that? I know you have. See how this all builds up? Keep thinking along those lines, or start thinking along those lines, okay? Come on down a couple of sentences. It says melanosome either enters the cytosol directly, that means it would go into through the cell membrane, or enters the extracellular fluid next to the keratinocyte. That would be like the matrix, wouldn't it? After which the keratinocyte takes in the melanosome by endocytosis. You see, it just keeps building. The melanocyte is transported to the region superficial to the nucleus, where it shields the DNA of the keratinocyte like an umbrella. The pigment eventually breaks down and goes away. Okay. So go look at the last paragraph. Melanin synthesis increases upon exposure to UV. You knew that. You get browner as you get stay more into the in the sun. Okay, we got a little bit more to go, and then we're going to close it out. 172, still talking about these melanocytes. Look at the first column, and you see it says, which causes the melanin to rapidly darken. UV radiation also damages the DNA of the melanocytes. Now, the melanin protects us from the ultraviolet radiation. So you see, that's sort of a homeostasis type thing also. It's trying to keep things normal because ultraviolet radiation tends to damage DNA. Come down to the second paragraph on 172, the first column, function of melanin, protect the DNA. We've already mentioned that. From mutations by ultraviolet radiation. Come on down about 3 lines and it says, the melanin does not provide complete protection. It absorbs some of the radiation, but not all of it, especially if the radiation is intense. Now, you see this old bald head up here and all these spots on there? And my dermatologist says, if you're going to be outside for more than 15 minutes, I want you to put a cap on, because I already have some damage right over here. Homeostasis, okay? Now, notice it says in this It says absorbs some of the radiation, but not all of it, especially if the radiation is intense. For this reason, people of all skin pigments can develop skin cancer. Come to the next paragraph. The second function of melanin is to decrease the production, the synthesis, the making of vitamin D in response to UV radiation. You say, why would you want to stop that? Well, let's take a look and see. This comes back to another homeostatic mechanism. Look at, come down where it says in response to UV radiation, come down to the next, skip a line or two. The answer is that vitamin D levels must be kept within a specific range, as excess amounts of vitamin D can lead to calcium imbalance and kidney failure, because the vitamin D helps absorb calcium. But we don't need to absorb too much. We need to absorb the right amount that the body knows is the right amount. That's why they told me a couple of years ago when I went for a physical, and the internist says you're a little bit low on vitamin D. I want you to go out a couple of days a week, maybe 10 or 15 minutes, and that's it. Get some sun. I've known people who do that. That becomes part of their regimen during each day. Me too. Now, you may not do that. He just said 10 or 15 minutes. That's it. Up come the vitamin D levels, and they're just right. Okay? I want you to look at the last paragraph on page 172, first column. Interestingly, the number of melanocytes is virtually identical. I'll get it out. It's 627. I haven't had any coffee or anything like that. Identical among all individuals, irrespective of skin color. It's just that we produce more melanin. Look at the last 4 lines about albinism. I've seen 2 or 3 people in my lifetime. I'm 73 now, but I've seen 2 or 3 people who are albinos. Some of you may know some of them. And they have to watch themselves in the sun. They have to cover up. They do not have that protective mechanism of having the production of melanin take care of their bodies. Okay, we're going to stop here. We've been in here for 53 minutes. Probably later this afternoon, I'm going to come on and make up, finish up the chapter, and then we'll move into histology. So be on the lookout. I had a hassle trying to get this thing going this morning. I hope it won't be quite as tough this afternoon. Anyway, you got my email, so if you have questions, shoot them to me, and I'll do my best to answer them. Okay? You'll have a good morning, good work, or whatever you're going to go to. Take care of your kids or something like that. And I'll be doing the next one. Next video. Thank you so much.